Hey everyone, welcome to another YouTube video. And in this video, I'll be talking about Kafka consumers, its overview, consumer configurations, commits and offsets, and what is rebalancing listeners, and what is the main difference between a standalone and a consumer group. So without any further ado, let's dive right in. So before I dive right into these diagrams, I will explain what a consumer is. So consumer is an application that reads your data from Kafka topics in your Kafka cluster. So like producers write data into your Kafka topics present in your Kafka cluster. Consumers are used to consume or read data from the topics. So these four diagrams will explain the different scenarios in which your consumer or consumer group will operate in your Kafka cluster. So if you look at the top left diagram, one consumer consuming four partitions. So let's say in this scenario, you have a consumer group where you have only one consumer installed or one consumer application active. So in such a case, it is subscribed to a topic or it is reading from a topic called topic A, which contains four partitions. And all the data from these four partitions will be read by a single consumer. If you look at the diagram at the right, you have two consumers present in your consumer group, which will consume mutually exclusive partitions. So what does mutually exclusive partitions mean? So it means that each consumer in a consumer group will read data from partitions that are independent of each other. So suppose consumer one is reading data from partition one and three, then consumer two won't read data from partition one and three. So it will read data from the remaining other partitions two and four. And coming to the bottom diagram, two consumer groups consuming data independent of each other. So in your software environment, you might have multiple consumer groups consuming data for different applications. Like you might have a website where your backend team will be accessing data from the same topic. At the same time, your ML and analytics team will be consuming data from the same topic. So these two should be independent of each other, right? So in that case, two consumer groups will be used for separate applications where they'll be subscribed to the same topic and consuming the same data. So this provides a nice separation and decoupling layer that doesn't overlap any two teams. And due to this decoupling, Kafka is very highly scalable in a production grade environment. And coming to the last diagram, the bottom left, excess consumers in a group compared to partitions. So if you have four partitions and in your consumer group, if you have five consumers, then one of your consumers is going to remain idle because the maximum number of consumers a consumer group can have is equal to the number of partitions in your topic. So if you add more consumers in your consumer group than the number of partitions, you are simply just wasting your consumer CPU resources. So it is recommended that you always remember that the maximum number of consumers that can be present in a consumer group is equal to the number of partitions present in the topic. And partition rebalancing in a consumer group. So what is partition rebalancing? So in simple terms, it is moving partition ownership from one consumer to another is called a rebalance. So why do we basically need a rebalance, you might ask? If you go back to this diagram, two consumers consuming mutually exclusive partitions. Uh, look at the top right diagram. So in that case, we have four partitions and there are two consumers and each consumer is consuming data from two partitions. Suppose your consumer one goes down or if your consumer one stops for some other reason like a network failure or if there is a server failure, something like that, and your consumer two is still running. In such a case, data will be read from partition 2 and 4, right? And what happens to partition 1 and 3? Data will get populated, but it won't be read, right? In such a case, if consumer 1 is down for a longer period of time, then a rebalance will occur. That is, partition 1 and 3 will be assigned to consumer 2, and the data will be read by consumer 2. So in such a case, we won't lose data in case if a consumer fails in a consumer group. And due to this rebalancing, we will receive the data from the other partitions as well. So this is why a rebalancing is required in case of a failure. So when does this partition rebalancing in consumer groups occur? I told you one scenario where in case of a consumer fails or if a consumer leaves from a group, then a rebalance is triggered. So apart from that, if you add a new consumer also, a rebalance will be triggered so that this new consumer will be able to consume data from partitions and reduce load from the existing consumers present in the group. And finally, when you add partitions to a topic, to scale your topic in case if the data load is large, then a rebalance will occur among the consumers in a consumer group as well. So what are the types of rebalances? So mainly there are two types of rebalances. One is eager rebalance and the second one is cooperative rebalance. So in eager rebalance, all the consumers stop consuming. They give up their ownership of all the partitions and rejoin the consumer group, and they get a brand new partition assigned. So when all the consumers are revoked of their partitions, then there will be a short window of unavailability in the entire consumer group. So this window depends on a number of parameters, the size of the topic, the number of partitions, and your consumers, the number of consumers and the consumer group resources, etc. So eager rebalance is okay in case if the number of partitions is less in your topic, then it is fine if that all consumers stop for a moment and then all the topics get reassigned. So in case if the number of partitions is very large and the number of consumers is also very large in a consumer group, this won't be an ideal scenario because there are just too many partitions and a lot of incoming data is flowing. In that case, a short window of unavailability won't be feasible. In such a case, cooperative rebalances, also known as incremental rebalances, is the way to go. So in cooperative rebalances, only a small subset of the partitions from one consumer to another will be paused. Like for example, if one consumer is consuming 3 partitions and the other 2 consumers are consuming 1 partition, then suppose like I want to assign 1 partition removed from consumer group 1 and consumer and to be assigned to consumer 3 in the group, then only these 2 consumers will there be a momentary change where there will be a pause in consumer 1 where consumer 1 wants read data from partition 3 and it will get reassigned back to consumer 3 will read the data from partition 3. So in this case, the consumer 2 in your current group won't get affected at all. Next one is static group membership. So by default, the identity of a consumer as a member of its consumer group is transient. So what does that mean is that in your consumer group, let's say the name of this consumer group is my analytics consumer group. And in this consumer group, there will be 3 consumers, let's say, for example. So they are assigned as a number like 1, 2, and 3. Suppose if consumer 3 goes down and then after some time, I'm adding a new consumer, it will be assigned with a new member ID like consumer 4 or like that. and a new set of partitions will be prepared and through the rebalance protocol. So if you don't want that to occur, if you want to have a static group membership, that whenever you restart your consumer, there shouldn't be a rebalance due to high load or high cache of your application. In such a scenario, uh, instead of this transient nature of consumer group, you could make a static member, you could make it as a static member of the group by assigning the group instance ID in your properties. So it is useful when recreating your data caching is time consuming, and you don't want this to process every time when a consumer restarts. It is important to know that static members of consumer groups do not leave the group proactively when they shut down, and detecting when they are really gone depends on the session timeout configuration. So don't worry about the consumer configurations. We'll cover in depth in this video itself. I'm just like giving you a brief about what a session timeout is. So session timeout is basically the number of milliseconds a consumer group or the controller will consumer group coordinator will wait, and post this time the group coordinator will consider this consumer as dead, and it will assign another consumer. I mean, it will trigger the rebalance protocol to assign the partitions among the remaining consumers that are active. So we'll go through this in detail. What is session timeout MS, and how will consumers interact with the group coordinator? That is, uh, how will they interact? How will they keep sending messages that they are still alive? And what are heartbeats, etc. We'll go into detail when we are discussing about the consumer configurations. Thread safety. So if you are from a Java background, you would know about multi-threading and thread safety and the importance of that. So the thing is that you can't have multiple consumers that belong to the same group in a single thread. And so, and also you can't have multiple threads safely use the same consumer. The rule is that you have to have one consumer per thread. That is the rule. Else there will be some issues during committing and offsets of data. So what are commits and what are offsets, you might be wondering. So whenever you read data from a partition in a topic, Kafka will send a message to the broker that they have read this data and please commit this offset. I've read data till this point. So don't worry, in the end, I have a diagram that where I'll be explaining about commits and offsets in detail. So you just have to understand that whenever we read data, a commit is made across an offset in your Kafka cluster. So this will become an issue if you have multiple threads using the same consumer. So in such a case, you can only have you can always run one consumer per one thread. And if you want to know how to do this, there is a very nice blog in Confluent that explains about explains in detail how to have a consumer group with thread safety on if you are writing a Java consumer applications. You could I will leave this link in this presentation itself. You can go through that if you want to deep dive and build applications in Java consumer groups. So consumer configurations. So before we go into consumer configurations, I would just first like to just show a hands-on demo in Python and how to build a consumer client application and how to read data in Kafka, how to read data from your Kafka topics. So let me just show you that first. Before I go into the code, I'll just turn up my cluster. So I'm using a Docker setup, and like how do you use this Docker setup? I have already explained in the initial video in the Kafka overview part 1. So if you haven't watched that, then please do watch that first before coming into this lecture. So let me just do a Docker here. So okay, my zookeeper and broker Kafka broker is up. So I will just, before diving right into the code, I will just create a topic first. I will name this topic as my topic and my bootstrap service 9092, and then just create this topic. Let me use this topics. Okay, I have two internal topics, and my topic which I created right now is present. That's cool. So I'm using the Confluent Kafka library, and I'm importing consumer and topic partition. So I'll just explain about the consumer object first before diving into topic partition that comes later on. So from Confluent Kafka, I'm importing this consumer class. So if you press Control and click on that consumer object, it will be directly going into the library code. And if you scroll up, you can see the consumer class, and under the params dictionary configuration, you can see that at a minimum you need to have group ID and bootstrap server set. So I have my bootstrap server that is localhost 9092, which is the Docker container that I've activated right now. And my group ID is my consumer group, and auto offset reset is earliest. So I'll explain about this property as well. So just bear with me. Currently, there for auto offset reset, you can have earliest or latest or as none. So I'm just keeping it as earliest. So I get all my records when my consumer group starts, so that I don't miss anything. And I'm subscribing to my topic. So you can subscribe to multiple topics. So there is no restriction that, let's say, for example, you have a traveling website where you offer 3 categories of service. One is for bus travel, and another one is for train travel. The third one is for airfare travel. And you want to collect data from, let's say there are 3 Kafka topics related to these 3 segments, and you want to collect the entire travel metrics by a consumer group. You could just present it as air travel, train travel, and then bus travel, all in the same area. All the data will be read. So you can actually subscribe to multiple topics as well. And here the code that I've commented out. So you can either subscribe to a topic, or you can directly assign a topic partition. So let's say if you have gone to the producer lecture, you should be knowing that key is influencing. The producer will be able to send a key value pair of data, and key is an optional field. But if you send data with key, then that key will influence the partitioning in your Kafka topic, right? Let's say if my topic is air travel, and I have a partition, 3 partitions, 0, 1, and 2. And 0 will contain all the data from a particular air service like Air India. In such a case, I could just, if I want to receive data about Air India alone, I could just directly assign that topic name and assign the partition number as 0, and then receive the data from there. So if I'm pretty specific and pretty sure about my data, I could directly use the assign function to get my data. or else I could use the subscribe method and receive data from that topic and its relevant partitions. Initially, I'll just go with subscribe. I'll come to this later on. So basically, a consumer application is an infinite loop which keeps on polling the Kafka broker to receive its data. So what do I mean by that is that uh, for every poll, you can actually set the time here. So what this is poll 1.0 means that this consumer present in this consumer group will call the Kafka broker every 1 second to see if message is present in my topic or not. If message is none, then it will just keep continuing the loop. Or if there is an error being thrown, or if your Kafka broker goes down, an exception or error will be thrown. So this exception will be caught over here and it will be printing that error that is being displayed. And finally, if message is available, then I'm printing that message. Usually this will be written in a log or in your database. But for the simplicity of our application, I'm just printing it in my console. And finally, your consumer has to be closed. So since this is a loop, how do you think it will be closed? So you can actually call this close in another thread, or you could just set a timer or somewhere over here. Like after a few hours, you can close this consumer application where this loop will get exited by an if condition or something, and then you can close it. In a Java-based scenario, usually you will call the consumer close in another thread in the background to close your consumer gracefully. So more about that later on, or if you want to deep dive, you could take a look at the blog that I've attached in the lecture slides. And these are the various other useful libraries that you can use while you're building your consumer application. So now I'll just simply start this loop and see if messages are being consumed. After that, I will explain about this as well. So you can see that my loop has started. So I'll just enable a simple producer in my terminal and type some messages. The producer is active. Hello. This is then from my terminal. Okay. As you can see, I'm able to receive messages that I'm sending through my producer. So if I increase this poll duration over here, then I will have a delay in receiving my messages. If nothing is specified, then whatever message that I type, I will get my response immediately because it will be keeping, there is no poll interval over here. And the few other APIs are pause and resume. So that allows to stop and receive from consuming from a set of partitions. So the consumer will still stay subscribed. So no rebalance will occur, but just does not fetch any new records until you have called the resume method. So this might be useful in case when you need to process the messages that you have consumed and your processing would take a little bit more time than required. Then in such a case, you could just pause pause consuming your data, just process your data, and once it is done, you could enable resume. And unsubscribe, it allows consumer to change your subscription. And if you are not subscribing to any other topic, the consumer will stay connected to the cluster. seek, it will consume data from a topic partition at a particular offset. So there is another method called offset for times in our consumer class. So what does this method does that is you have to pass your topic along with your partition and a timestamp. Let's say my consumer application is consuming data every day from 1 to 2 p.m. And one day it failed to consume data from 1:30 to 2 p.m. And in such a scenario, I need to read the data from 1:30 to 2 p.m. Now I know the timestamp where it should start, that is 1:30. So I could just send the topic name, its partition, and the timestamp, and then I will receive the offset that is available at that time. So once I receive the offset, I could use the seek method, and by incrementing that offset, I'll be able to read data from 1:30 to 2. So seeking data and this offset for times is used to read data at particular time intervals in case your application fails, and it will be useful in such scenarios. List topics, this if you call list topics method, a cluster metadata object is returned where you will get information about your broker, controller, and then your topic information as well. So let me just stop my consumer. I'll just comment out the link and subscribe as well. I'll do list topics. Printing topic. So I think this is the controller ID. So this topics, I go into this method. So its return type is cluster metadata. Let me just go to it and open the console. Python documentation. If I go on the consumer, I will have to check it for list of return type is class metadata. Python. Method provides the same information as this topic described. Topic described cluster in Java implying return type is cluster metadata. Okay. So this class is typically not user initiated. So these are the available variables. Okay. So if I go here, what are the available variables? Cluster ID. Cluster ID. Now we print a few topics. Topics indexed by the topic name. Okay. We have topics here. We have brokers. Just name my topic directly. The topic and run this code. So first one is the cluster ID, cluster which we are connecting. Next one gives the information about the topic, my topic. And since there is only one partition topic, it's displaying that. Brokers, yeah, in my broker bookkeeper setup, only one broker is present and its address is localhost 9092 and its broker ID is 1. So this list topics provides some relevance for getting information about our Kafka brokers. Okay, next up is we'll try to run the assign. So this is the topic partition object. So in this object, I'm passing my topic name along with partition ID, which is 0, because there's only one partition that you could see from my list topic method, whatever it has returned. So in such a case, I just run my loop again. Let me type some messages. Yes, I'm receiving messages even using the assign method as well. So, okay, this was a quick overview about how to create a consumer applications to subscribe topics or to assign topics and specific partitions to read from in case of super specific scenarios, and how to use the list topic methods to know about your cluster information like cluster ID and your topic informations and how many partitions are available in your topic, and get your broker information as well. And apart from this, you've got a brief overview about the pause and resume method, unsubscribe method, seek, and offsets for time, etc. Go back to our lecture again and we'll resume the consumer configurations. So you might have noticed in our Python applications, I specified the group ID, bootstrap service, and auto offset reset. Out of these three properties, two properties are mandatory, that is the bootstrap service and group ID. And auto offset reset is an optional parameter. So apart from those two mandatory properties, there are many other consumer configurations that you could incorporate in your consumer applications based on your needs and scenarios that are being required. So first one is fetch minimum bytes. So as the name suggests, what does this property allows is that you would set a minimum number of bytes over here. So fetch minimum bytes is that by default, the fetch minimum bytes is 1 byte. So let's say if you specify it as 1 MB, your Kafka will only retrieve records from the topic partitions when 1 MB of data is available to read or 1 MB of data is available to receive. So suppose in case if 1 MB of data is not available, then this fetch max wait MS property will come into play. Let's say if my fetch minimum bytes is 1 MB and my fetch max wait MS is 5 seconds. So my Kafka consumer application will either wait for 5 seconds, or if 1 MB is achieved within 5 seconds, and 1 MB of data will be received by the consumer. If only I have 0.5 MB of data and 5 seconds have passed, then my consumer application will consume 0.5 MB of my data. Next one is fetch max bytes. By default, 50 MB is the upper limit, and you can change this property as well. So this is the maximum number of bytes that will be received by your consumer applications from your topic. So this property can be set from the broker side as well by your admin, Kafka admin. And usually it should not be very high. If a very high value is given, then your consumer CPU resources and as well as your broker CPU resources may face an overload, and it could create some feasibility issues as well. And the next one is client ID. So this is different from your group name or group ID. So client ID is much it's an optional and much more broader ID, one can say. So client IDs are usually assigned to a team which will contain multiple consumer groups, and it is usefully in case of debugging to understand where, in case if there is some performance hit or something, or in case if there is some resource crunch, and if you want to know which client is consuming the maximum amount of resources, in such a scenario, client ID would be useful for this type of logging and tracking. Next one is the client track. So if you are using a single cloud setup or an on-premise Kafka setup, then client rack won't be of much use. But if your Kafka service expands over multiple data centers, in such a case, client rack should be specified in your consumer group properties. This is an issue for latency because Kafka always consumes from the leader ISR. If you have followed my previous lectures, you would know that Kafka will write and read data from the leader ISR. So in such a case, when your Kafka cluster is expanding multiple data centers, multiple data zones, then if you have your consumer application in one region, that is US West, and if your data center leader replica is present in Europe or in a Singapore region, then there will be a huge latency over the network. In such a case, you want to read data from the ISR that is nearby you. That is only achieved if you have passed this client track property explicitly in your Kafka consumer group property section. Next one is group instance ID. We have discussed about the static group membership. This group instance ID is transient in nature. If you want to maintain static group membership, then you have to pass this group instance ID as well. Next is enable auto commit. So whenever Kafka polls data, it polls data, it receives the data, it processes it, and it will poll for the remaining set of data. And this process will repeat infinitely until the while loop exists. So whenever you read data, that when you poll data from the consumer, then the consumer will send a metadata to your Kafka broker that it has read this much amount of data from your topic, and this much amount of data from your topic, and it will be committed that I have read this much data, and I don't, in case if my consumer stops or restarts, then I have to read data from this particular point. So if you enable auto commit, then this committing will be enabled. Uh, so if you enable auto commit to false, then you have to create your own committing logic uh, for your Kafka application. It is not recommended, but if you have a special scenario, then you can enable auto commit into false and create your committing logic. Next is auto offset reset. So yeah, there are three properties in auto offset reset, that is earliest, latest, and none. So if you give auto offset reset equal to earliest, in case uh, if you have lost your commits, or if your Kafka consumer application crashes, and if it is earliest, then Kafka will start reading messages from the earliest available message that is present. Suppose if there are 10 messages and your consumer crashes, and if there are no commits available in your Kafka system, then it won't read from 9 and 10. That is post 8 that you have already read. So if it is earliest, then it will start reading from 1. So if it is equal to latest, auto offset reset equal to latest, then in such a case, it will read from 9 and 10. That is the last available commit offset. So if it is specified as none, then if you don't have a commit offset that is being present in your Kafka topic at that moment, then in such a case, your consumer will throw an exception. Next one is session timeout MS and heartbeat interval MS. So yeah, during our consumer group overview, I told you I'll explain this property in detail here, right? So session timeout MS is simply the time your group coordinator uh, will wait for a consumer, and post this time, the group coordinator will consider your consumer to be dead or shut down, and it will remove that consumer from the consumer group, and it will trigger a partition rebalance. So how does this group coordinator and your consumer will interact? So they will interact by sending heartbeats at regular intervals. So this heartbeat interval and session timeout interval are like two properties that has to be set together. By default, the heartbeat is set to 1/3 of the session timeout interval. So if you are setting your session timeout interval as 3 seconds, then your heartbeat interval should be set as 1 second. Next one is maximum pole interval MS. So default value is 5 minutes, and it is triggered only during a deadlock. So what does this deadlock mean? So your while loop is an infinite loop that will continuously poll the Kafka topics. So in case when you're polling some messages, if some messages are corrupt, and if this process gets stuck in an infinite loop, then your Kafka won't poll your records anymore, since it is being stuck during processing stage. So if your records is not being polled, then after if it is not being polled, but uh, the heartbeat interval keeps on sending keeps on sending heartbeats, then your session won't get timed out, right? So in such a scenario, if you haven't polled for a given particular duration, then your consumer would be considered dead, and a rebalance will be triggered. Next one is partition assignment strategy. So initially, if you look at those diagrams, you would see that partitions will be assigned to consumers present in a consumer group, and they'll be mutually exclusive of each other. So the various types of assignment strategies are range, round robin, sticky, and cooperative sticky. So range is like if a particular range is being assigned for a single consumer. Let's say if there are like 4 partitions in one one topic and you have 2 consumers, and your range, let's say for example, is 3 partitions. So 3 partitions will be assigned to the first consumer in a consumer group, and the last remaining partition out of the 4 will be assigned to the consumer group 2. So this creates an uneven balance if your range is not specified correctly. So in these cases, round robin is being used. So in that way, all 4 partitions will be divided equally among the consumers in a consumer group. And next one is the sticky partition assignment strategy. Consumers can subscribe to multiple topics, not only a single topic. When you're subscribing to multiple topics, assigning partitions among your consumers in your consumer group, round robin might create an imbalance. So in those scenarios, sticky partition assignment strategy is being used. And finally, for cooperative sticky, the same purpose is that to assign partitions evenly when your consumer group is consuming data from multiple topics. And in what does this cooperative sticky does special when compared to your sticky partition assignment strategy is that it allows cooperative rebalancing. Yeah. So in sticky, only eager rebalancing is allowed. In cooperative sticky, cooperative rebalance is allowed. And finally, commits and offsets. So this is a visual representation how data, how offsets are present in your Kafka broker topic and how commits are made by your Kafka consumer. So if you look at the top diagram, there are like 11 messages from 0 to 10. And if you look at that, the last committed offset is at 2, and the current event processing is the last old records. So in case if your consumer stops or if your consumer crashes at this point, and if it is restarted, and if your auto commit, if your auto commit reset is equal to the latest, then the last or the latest committed offset is 2, then you will be processing 3 to 8 again, thus inducing duplicates in your consumer application. And if you look at the bottom diagram, you can see that the last committed offset is 8 and you're currently processing at 4. And in this case, when your consumer crashes and again comes back online, and since your last committed offset is at 8 and your current processing was at 4, you would have lost the messages 5, 6, and 7. So for your software application, to manage these commits and offsets, you have to note down these 2 properties. That's enable auto commit equals true, and then the auto commit interval ms. So by default, the 5-second interval is good for 99% of the time, and most of your records would be processed. But in case if you have a sensitive application, then you might have to write your own specific commit logic. And if you're interested in looking more about committing your own offsets, then you could check about the commit sync and commit async APIs, where you can directly use these APIs to commit your offsets in your Kafka topics. So this is the overview about Kafka consumers, and I hope this video has helped you learn about it and how to build a hands-on Kafka consumer application and what are the different rebalanced and partition assigning strategies and what are commits and offsets. So if you have followed the lecture till now, you'd be able to answer around 70% of the questions asked about Kafka in interviews. So apart from this, only Kafka schema registry and Kafka Connect are the other 2 important topics that you should be knowing about. So Kafka schema registry talks about data versioning and data control in a Kafka system. And Kafka Connect is used to import and export data from various different sources. So don't worry, I'll be covering that in the future videos as well. So until now, if you enjoyed watching these videos and if you have learned something, then do like, share, and subscribe.